How's it going, everyone? Welcome to another video on the enterprise UI development. Euler Gonzalez here. And today we're going to talk about is now how we can make this build system using GitHub. And you may wonder, what is that? If you have seen my videos, if you have saw my previous videos, you'll know that over the couple videos, I have now created this storytelling as a way to understand how do we get here, right? Which means is, what is this build system? Why we are looking at this thing, and what does it mean this, and what, to be honest, what is the enterprise UI development? So in today's video, we're gonna quickly answer those questions and then move on to what we really care about, which is actually doing the hardware, which is doing the testing, get my hands dirty, and you are going to follow me along with. So let's begin, shall we? So, because this course is taught by Steve Kinney, head front-end engineer at Temporal, which is a very interesting company. They have now these open source tools that is pretty much like managing the orchestration of environment, and I think that's very, very awesome. So like Kubernetes, which is now manages the orchestration of Docker, and Dockers is this containerized application that have everything that it needs just to be deployed on any machines, regardless your hardware, which is a great thing given the huge diversity of Pokemons out there, in this case of hardware. All right, so you have not only or hardware architecture or CPU architecture, right? So you have now, for example, different you have the x86 as well. You also have now the ARM architectures, and then other competitor, but those are the main two competitors, right? I would like to also ask here Perplexity as a way to understand, to fill my gaps here. What are the architecture the CPU architect? Oh my god, what the fuck, come on, what Vietnam, what this auto completion feature, what are the PC architecture, what in Vietnam companies right now, or in at 2024, right? Interesting. So now NVIDIA actually launched that. Average salary, well, computer architect. So you have NVIDIA, you have Intel, NVIDIA, but NVIDIA is for GPUs. Okay. Intel, AMD, all right. As well as Boeing is also in that field, primarily known as aerospace. Boeing also engaged in advanced computing solution for its aircraft and defense systems. Makes a lot of sense. Makes ton of sense. No, but this is company that invest in here. Tata Group, Tata Consulting. No, but again, leading PC architecture companies. Oh, Boeing is quite interesting. It makes sense. I didn't thought about that, but Boeing, because this is one of these small defense contractor in the U.S. Along with Raytheon and what? Okay, here we go. Along with Raytheon, Lockheed Martin, Airbus. Boeing, that's interesting. It makes a lot of sense, especially for the defense and aircraft system. Interesting. Okay, Meta as well is investing in that. Synaptic, interesting. Infinity Computer Solution. Interesting. And Tata Group, an Indian multinational conglomerate with interesting IT service through Tata Consulting Service. So, what I'm going to mention is the first 5. So, NVIDIA for GPU, Intel is for designing microprocessors, as well as AMD, okay, as well as Boeing for defense in their aircraft system. Interesting. So this is because each one of these PC manufacturers, okay, or PC architecture companies manufacturers, they rearrange all of these elements for a particularly or with their own ingredient, with the all spicy secret sauce. Now we have the ability to run, as long as they use some of the basic stuff that allow to run Docker, we can run in any of these machines this kind of application. So this is quite interesting. Very, very, very interesting. I know that I need to dedicate time as a way to understand how all of this architecture come and what is the history of this architecture in the company. Okay. Let me okay. I'm recognizing it's a gap in my knowledge. It's like I definitely need to really take a look at that, because otherwise I wouldn't be able to know what am I talking, and that's not good for business or for someone that provide value. It's like, yeah, good, you're working with that, but you don't know the intrinsic nature and how to explain that. You know, you just work mindlessly in that. Why? No, that's not a good deal. Yeah, computer science from I think it is. The introduction of computer science, I think it is. Yeah, my friend, totally. Introduction to computer science. Yeah, my friend, I definitely need to look at this. And then if you want to pay for the title, well, that is very good, because they're gonna test your knowledge and that kind of thing, blah blah blah. Anyway, but yeah. Interesting. Yeah, this is for free. It's online. Okay. Yeah. Because I recognize that there is a gap in my knowledge, I'm going to. Oh shit. Okay. Yeah. Okay. Cool. Cool, bro. Cool. Because I recognize this gap in my knowledge, I'm gonna do something about it. I'm gonna freaking fucking do something about it. And that is the CS50 intro. Yeah, my friend, it's like intro. Yeah, bro. Oh shit. Intro computer science. Intro computer science, right? Computer science. Yeah, my friend. Yeah. A broad and robust understanding of computer science and programming. Yeah, my friend. Yeah. Oh my god. Yeah. It's more likely for computer science. More likely for computer science. Yep. Yeah, totally, bro. Completely. End discussion, bro. and discussion. I would like to start that in there, right? Yeah, it might take. Yeah, that might take me is. I hope that a month, but I will take a little bit more than that. Yeah. Yeah, this is DevOps, and computer science. And computer science, you know, because I definitely need to know about who am I talking about. Yeah, bro. Yeah, computer completely. I need to definitely know about that. Not for the recognition, it's for myself. And also that others are, they say, okay, you have dedicated time to do this. You're not someone random that you have some very well articulated. You express yourself in a very convincing way. You have persuasion, good. But what about the practice? Show me, don't tell. So that's one of the things that I'm going to take. Yeah, completely right. Oh, my friend. Oh yeah. So in any case, because of that, right? That now, this is talking about temporal, right? And again, briefly talking of what temporal means. Correct me if I'm wrong. Any of the people that work in Steve in temporal. But the goal of this course is to understand what are the necessary things to maintain large code bases for companies or even for yourself, most of the time for companies, with a wide range of contributors in a large team. So it means that we need to understand what maintainability means. What is the concept of maintainability means in software? Okay. Also look at a couple examples out there of the software. So for example, what maintainability means for a fridge, or for a oven, or a motorcycle, or a bike, or to maintain your physical health. You know, each one of them requires specific, very different, most of the time, things to do. So that is something interesting, because now when we need to define this maintainability, or this step things that we need to do, we need to understand is what are the things that allow to maintain something, and in this case, code. So we can briefly describe is that when we maintain, for example, our bike, so we need to is make the chain regularly, clean the chains and oil that, check for that the brake works as expected, as well as the seat. All right. If you have, for example, a fridge or an oven, or for yourself, okay, hey, I would like to take myself good. I would like to feel better. I would like to try to hit the gym and then eat healthy, right? So there are several things that you need to do along the way. So this is pretty much in the context of software. So not only Steve Keeney, but myself say, hey, you know what? Here, because we need is, how do you put it? Yeah, because we need here is to do certain things to actually maintain or guarantee the maintainability of a code, which is not only the ability to add code, but also to change it, data dependency, and do refactors without the fear of breaking something, or reduce that as much as possible. So because here we're going to look at what are the things that allows to set up this infrastructure, these basic operations, or this basic installation needed to guarantee that operations for its economy, for its judicious use of resource, okay, in large teams with huge code bases. The thing here, and according to the experience of Steve Keeney, you say, hey, the components of a well architecture UI, it must contain is a testing, a build system, a static analysis, as well as some deployment practice or some deployment infrastructure. Also, some of the design document, I think, is something they mentioned. In my case, is yes, okay, a separation of concerns between the UI and the logic. It makes sense between the UI and the business logic. The deployment, how we're going to now deploy that code, and do we even use CDN, content delivery networks, and some design process. It means that how we're gonna add features, how we're gonna bug fix, how we're gonna document stuff here. So I think this is something interesting, because at least it gives us at this moment what are the things that we as a UI specialist can provide to companies and to business. Okay, so because of that, all right, we look at the ingredients of a well-maintained or a sustainable architecture. Okay, this is the ingredients of this sustainable architecture, this sustainable infrastructure that we need to define is based on the needs in that particular project. You're going to define is, hey, do we have the basis, which is the system? Hey, this project contains now the testing system as well as the building system or static analysis. If it is, good. So let's go to now look at next step in our needs to make this architecture maintainable. Hey, are you following some code review? Yeah, are you doing some code review? Code review is something that is very quite obnoxious. Hey, you doing some code review? Are you having some blueprints when it comes to design new features or identify as bug fix? Are you also documenting your applications here? And last but not least is that once you already have that sort of, or already in an 80%, then you can start to think now, okay, so now that we have is this know-how. Anytime we encounter particularly problems in this know-how, in these processes, what are the patterns, the typical solutions when those happen? And that is now this particular pattern, this architecture, this which is, hey, so when we need to define as a build system, what is the pattern that we need to follow? What is the infrastructure that we need to follow? What is the architecture that we need to follow? If we're going the same for the testing, what is the architecture that we're going to follow? If we're going to manage our state, what is the architecture of this? So all of these recurring problems, okay, that happens, so we now have is this particular pattern. So common solutions to typical problems. Common solution to the typical problem is, for example, where do you leave your keys? French toast those keys, bro. So if you define now this and you develop this pattern, where you're going to put your keys in the same place anytime, you know that you already solved that problem. But if other people actually know about that pattern, they know where you put the key and they're going to eviscerate that or take that away. So the whole point of this is to recognize that when you have a problem, it is better, it is a good thing for you and myself to develop some habits to come up with that, come up with a solution after that, and understand why are you doing the thing that you do. For example, I'm trying to improve my sleep. I know this is go beyond the scope here, but just try to explain what is this particular thinking process that you can also do. So I try to fix my slip, right? And because there's a lot of things that I need to do, I try to follow is this particularly practice. So I'm gonna turn off the lights, and then I try to calm myself and take a hot bath, and not eat for that. Just drink water a little bit, not that much, because I don't want to wake up early at the night or the midnight, and then go to the bathroom. So this is all the things that I need to do. So, in any case, enough talking. So, okay. So, because of that, right, so now that we know what are the things needed, at least for this particular context, which is maintain applications in 2020 as a UI specialist, all right, we're going to see is the tools that we're going to use. So, React, TypeScript, Vite, Vitess specifically, Playwright, and testing libraries. Okay, so here we're gonna see is more a practical approach rather than a philosophical, because this is what we're gonna find in real life code bases in companies. So okay, that makes sense. So we went through this explaining briefly about what unit testing means, this particular system, the spectrum of that, unit, integration, and into and then you also have a component testing, and then where we're going to look at now what are the things, especially what we need to do when we go and write our unit testings. Why is that? Well, because this is something that is fairly cheap. Actually, it's quite fast to test. Is part of this specific step that we need to do as a way to guarantee the maintainability of our code. So we write this unit testing, and here we're gonna just set up the unit testing with Vite test. Look at how interesting is this, because it's using ESM, which is now a model bundler built on Go, which is much more faster to take more advantage of the multiple threads of your CPU, which is a great thing. Unlike Node, which is a single thread. They also now moving the development of Node to be something more like multi-threading. So it's pushing now the boundaries of JavaScript as a single thread language, which is quite interesting. And it also going to some trade-off and challenge along the way. We also look at how compatible is this. So this VTest is actually ESM compatible, which is this new way of organize your model. How easy is to migrate from Jest, this JavaScript testing library, to Vite, and how easy is now, and how helpful and how convenient is now this error reporting that provide Vite. So after we look at that, we're going to write our test, or we wrote our test, which is something that we did. We're gonna move on to the next one. So we wrote our tests. We look at some advanced patterns, especially when handling async scenarios, as well as the how now. So we're gonna go into our first forage of setting up our build process in a way that allow us to run the affirmation tests to check that everything works as expected. So some couple definitions, so for example, like assertions, test, and test suite. What does it mean by that? And actually now a more hand approach here, which is something that we're starting to do. So if you want to test your JavaScript application functions, it is important to understand how now that JavaScript works. I go beyond the scope. We're assuming that you already know how JavaScript works. If you're not, you can take a look at some other courses that actually give you now a more broad incentive, a more perspective as a way to understand how you can talk to JavaScript and this particular interface between the language, the human, and what is doing behind the scenes, as a way to talk to the electrons, because at the end of the day what you're doing is just you're some sort of magician here. So you are now through these human language with some sort of keywords, you are now telling to the machines to do things for you, to compute things for you. That's quite interesting. Anyway, here we look at, especially when you are writing your JavaScript functions or your JavaScript tests, you want to test your functions. It's important to understand is, well, that when you are now assigning values to a primitive, to an object, is different how that works, and especially if you want to compare that, we need to know what is, or we look at what is the referential equality, as well as shallow equality and deep equality. Okay, so shallow equality is going to take a look at all of this list of property and their value. If they are the same, good. Deep equality do that for any nested object that you have, or any level that you have, right? You can use this now an expect function to actually guarantee or to check that. So the to be is doing this referential equality, and the to equal is doing is the value equality, right? So the greatest hits that we also look is also the greatest hit that we also look, which is the greatest hits. This is a list of the greatest hits. For example, the to be close to, as a way to now check is for float pointing values, and they use that as a way to say, hey, you know what? I don't know why my nose. Okay. Yeah, I don't know. Okay. So yeah, the to be and to be close, which is actually checking is this floating point. That's right. Yeah, it's to checking this. Checking this point floating equality here. There's something interesting here with 0.1, 0.2, which is now how the way it represents this number as fractions, and then you have now clean fractions and repeated fractions, and that leads to a lot of programming language to now have a way to solve this particular problem. This is there is a particular website out there you can find that, which is a great, but this course is not about that. Okay, we also look at the to be instance of, which is going to take a look now at the prototype or the proto, if that have a reference to the object function or to the function construction. What does it mean is that, again, JavaScript, as we know, is a so functions are first class citizens, as they like to call, which means that now everything in JavaScript is an object, but functions has a specific, it's a special type of object that is also callable, right? So you can now add properties to this under the prototype. Okay, you can add all of these properties as well as their value. And it has now the ability to execute that. So you have now this function constructor. So this is what to be instance of is doing. In this particular object, because behind the scenes, the way how they can have access to other property as a way to improve memory use is to say, hey, you know what? Let's go to create a reference to another object where it's going to have access to all of the property and methods through this reference called dunder proto dunder. Another word, underscore proto underscore, which is a great thing, right? So now you have this reference. So to be instant, what it's doing is to check now if that object has a reference, which is the proto, to the function construction. And if it is, great, cool. You have now an instance of this object is an instance of can have access to this property and method. Okay, the to contain is actually check if this element now belongs to this list. To throw error is pretty much for functions. When you want to check if a particular function actually throw an error. To match as a way to check if the string exists in a substring similar to the to match object, but in this case it's for objects, so it's going to compare if this object that you have here completely the full structure of the object actually match to this. And spec any is to check instead of the value we wanted to check is the type. Great, good stuff. There are also some bonus here. So for example, expect array containing, okay, wherever this array has, I just want to see if one of these elements contain this. Similar for objects, okay, expected object contained. So because I want to use this now to check the equality here. For example, here I want to check out the equality. So I don't care the shape of that object, but as long as that contains this particular property, which is the expected object containing URL, and I using is that must contain is to keyback title, okay, good, which is of course our functions do that. So the whole point of this, especially when you're writing, or the key takeaway of writing your function is, or writing unit tests is, first, when you're writing your test, define the setup and also the testing logic, and last but not least, the expectations. And when it comes to now build your applications, write functions that encapsulate that logic, right? Small function that encapsulate that logic. So we also look now at when we need to, this is good for synchronous operation. What happens when we need to handle asynchronous operations? So now this application need to talk to external sources, right? Or we need to wait for those external sources to get them. So we can use this, the async and await, as one technique, or use the promise, the expected result or expected reject as a way to check that works as expected. When it comes to bug report, you take that report, you take the problematic code, okay, you write a test to that failed that. You write a failing test to make it happen, okay, to make it pass. And when it comes to handling now is timers on the UI here, there's some techniques that you can use. For example, like speeding up the time for that that needs to pass, useful for notification, loading icons, that kind of thing, as well as the date now. Okay, so with all of that, we also look at example of that kind of thing, which is a great thing. Okay, so here finally we're looking is at this the next step, which is the next step is talking about is building CI pipelines with GitHub Action, which is the build system. Remember that pyramid of Maslow, right? So this is building the build system. So what we're gonna do is to implement a CI/CD, testing and build, and generate covering reports, as well as saving playwrights video. This is quite interesting. So people are more willing to not doing anything or convince somebody to cut off them some slack than they are to turn off the build process, which means is that we all complain about the build process failing, but we actually try to make that happen, or to make that pass. So what are these GitHub actions? So the GitHub action is just a servers, or particularly is a process, okay? Is a process built in GitHub that automate your build, testing, deployment, so you can ship code faster and more reliable. And I think understanding this specific stuff is quite interesting. Why is that? Because you can now have as a better understanding that what is doing. When we talk about process, is this application that is running in the background, okay? Especially in the terminal. So this is quite interesting. This is not a CI/CD, so this is not a server, by the way. Not a bare bones server, because that's quite expensive. This is just a process that is running in one of those bare bones servers, okay? That actually what it does is to see, hey, I want you to now download all the necessary dependency. I'm gonna build the OS, as well as download all the necessary dependencies for your applications to run, okay? And then going to build the application that was expected, run the tests, okay, and then deploy that. So this is known as continuous integration and continuous delivery. There's also a term called the continuous deployment, where now that particular phase is automated. Depend of the applications. For example, if you're going to use that for, let's say, if your applications is on the medical industry, is on the pharmaceutical industry, is on the defense or any sensitive applications, you want to skip, you don't want to use this continuous deployment. You want to have now a human process, a human review process of that. It's not fun. I definitely might be not fun, but it's required, you know. So why I build this, you know, this Venn diagram, as a way to now understand that if you are a UI developer, right, you're gonna need to understand where you're going to overlap with other with other jobs or with other team members, right? So what are their roles and what are your roles and when they overlap it, as a way to provide value to yourself and also to themselves, okay? So in this case that we are now UI engineers, that our main role is to design and develop user interface as well as maintain. So when it comes to the maintenance, right, we want to now write some automated tests that make that happen. So that's why here we are slightly combining is this DevOps role, the DevOps engineer, when it comes to automate things that are manual. For example, running our tests, or right now it's just only running our tests, okay? And what are the things that we need to that we share with the backend engineers, okay? Which is user and data interactions. But at the end of the day, all the main goal of the intersection of all of us, all of these engineers, software engineers, is that automate stuff. Period. There is a value for that. For example, because now you don't need to what the hell is even this? Oh shit. Let's keep it professional. Let's keep it professional. So, so oh shit. Oh man. Yeah. They're terrible, bro. They're terrible. Because emotion management, man. Emotion management. Anyway, so yeah, that's what we are looking here, right? So now that we understand this particular role, it's also, exactly. So here we look, right? Here we look at the GitHub actions, right? So all of this is GitHub actions. Okay. So all of this is just from the GitHub action as a way to understand what is this. What is the main goal of this GitHub action? This build system is to automate this manual and tedious task. Okay, when it comes to testing, when it comes to run this test, at least right now, when it comes to actually check our code that the shape of the data is passing as expected, okay, as well as how can we now automate that process when it comes to not only test that application what is expected, build, run that test, and then deploy that, right? So okay, and also how can we now is not only automate is the design, because that's another one. Automate is the design and develop of user interface. This is something quite interesting because you can create some sort of particular patterns that are useful for specific use cases, right? What does it mean is that we have now here, for example, tailwinds, right? So tailwinds, I think the components. So tailwind now is providing you some of this specific user interface that you're going to design and build. So all the people that actually doing that to help you to cover some common use cases, right? So when it comes to actually develop this kind of application for all of that kind of thing, it's like, yeah, that's good, that's great. You know, it's like, yeah, that's good, that's great. But what happens when we are now need to create interface for what will happen when we need to create interface for other use cases? Okay, because this is something good. For example, for admins, you're building interface for admin dashboard. Yeah, admin dashboard, trading, video content base, text editor. Okay, good. But this is to cover all of this. Most of this I already created. It's important to understand how the mechanism works. But when it comes to actually now how you can develop interface for other use cases, for example, now how you can provide is data visualization in a way that is meaningful to humans, right? This particular topic, this exploration, all right, of the user design, because the user interface design, okay, user interface design. So what you're doing is that you don't care what's going on behind the scenes, especially with all of this data and all of these models that are competing each other. Okay, you just care is how you're going to provide that in a very useful way to others. That's where the value of this. Oh my God, that's where the value here kicks in. Oh hell. So a good example of this is like, if you have an oven, all right, most of us have an oven. Instead of you having to manually look it up and which cable that we need to connect as a way to now make the spark and make the spark and get a flame, right? So get the hot things going on, right? Get the fire. So make the spark and get the fire over my stove, right? So instead of you having to do that manually, which is something that you can do, it can be quite risky every time you do that. Again, you can do that. There is now an interface, there is this knob that allows you to actually do this. So similar to a door, it's like, hey, how can I access to this if there is no knob? What? You can throw that away. You can try to keep get yourself in by other means, which means that you kick the hell out of the door. Okay. Again, this interface is something. This is where the value of this UI designer actually provides. That's quite interesting. This is truly the best value that you as a UI designer provide. Because now those career mean is anything that where you can provide value, anything that you can provide sustainable value. I would like to know what career is, right? Etymology. Or a running a course, especially the sun across the sky, from French carrière, road, race course, from Old Provençal of Italian carriera, from Vulgar Latin carriera, carriage, road, track, four-wheel vehicle. the general sense of course of action or movement. It's from 1590, hence course of one public or professional life. To charge at a tournament. To charge at a tournament. To go with a tournament. The meaning move rapidly, run at full speed in 60-40 is from the image of a horse passing a career. So this is quite interesting as a way to understand what careers mean, and especially if you are when you are aware of what is the value that you are going to provide, which is something important, because at the end of the day, it's like if you not do that for yourself and you are just doing this work over and over and over in a repetitive, mindless way, again, that's machines. We are not meant to be that machines. So because of that, I just want to, they define here this career, and a career means is a running at full speed to a goal. All right. So from 50-30, a running a course, right? So you're running for a goal. A running a course, according to etymology of dictionary. Okay. From what? Especially of the sun across the sky. From career. Okay. So the word career, the etymology, the origin of that is a running a course, and a course has start and end. Okay, so what you're going to do here is to running as fast as possible until the end. Okay, and then learn from that. What are the things that are actually relevant for this or not? That kind of thing. Blah 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 blah. Interesting. And then you rest, reassess, to now run another career, or to now run another course. Oh my God, man. Oh my God. I know. This go beyond the scope of this. But what I'm just saying here, okay, is a way to slowly but progressively understand that is that as a way to slowly but progressively is to understand how do we get here, and what is the values, and what is the reason of developing and understanding all of this. So what is the value exchange here of this, and that makes a lot of sense. And that makes a lot of sense. So yeah, okay, be interesting. Okay, that's quite interesting. UI design skill. Design start with having the right skill. While not always required to get a job, earning degree or is one of the starting buildings to skill. Build your portfolio, bro. US assign books, blogs, and podcasts. A resource list. From the calls. Okay. To develop your UI skill, try to Google build dynamic user interface for website. That is part of the top rater US assigned certificates. Build dynamic user interface for websites. Beginner level. Again, this is for Google. This is for Google. Google UX Design Professional Certificates. Flexible schedule, 6 months or 10 hours a week. Yeah, but what is the outcomes here? Follow the design process, emphasize with users, define pain points, identify solution, create wireframe and prototype, test and iterate on design, apply foundational UX concepts like user-centric design, accessibility, and equity focused design. Understand the basics of UX research like planning research studies, conduct interview and usability studies, and synthesis research result. Create a portfolio of UX portfolio including end-to-end project so that you can ready to apply for jobs. But again, exactly, this is for that. Foundation of user experience. Most of the time you're gonna learn this on the job. Yeah, most of the time you're gonna learn that on the job. Again, this is something, okay? This is something that you can do, especially if you're going to, if you truly want to dedicate to that. Oh, this is the course structure. But it's professional certificate 7 course. Foundational of UX designer. Start the UX design process, emphasize define here, build wireframes and low fidelity prototypes, conduct UX research and test early concept, create high fidelity design and prototype in Figma, build design user interface for websites, design a user interface for social good, and prepare for jobs. That make oh shit okay so yeah okay yeah the other is system design. Software design and architecture. Object design. Design patterns, software architecture, service-oriented architecture. Again, I think the more exposed you are to this kind of content, the better off will be. But I think that this is something that I'm going to develop this naturally. I'm going to develop this naturally. And right now I'm looking is just at this, okay? Yeah, and right now I'm looking is just at as this, and like this, as a way to maintain these large code bases. So one step at a time. So when we need it, we're going to, if we're starting to see that we need to do that, that'll be great. If it's not, not. But the whole point of this is to understand that when you're building your system, we're gonna use this now GitHub Actions, because that is now this company GitHub actually provides you a process that allows you to build, test, and deploy your applications, right? So the thing here is to automate things that are quite tedious in your particular profession, which is when running tests, running or doing this static analysis as well, and that kind of thing. So we are looking right now is at one of the most common use case of GitHub Actions. So if you have now a company, or if you're working for a company that has several open source published to NPM, okay? Let's say you have a public repo with the open source code, and then a private with the SaaS, okay? When we bump up the NPM versions in a PR, that will automatically bump NPM versions in the cloud. So this is something great. So because now, instead of you not only bump the NPM versions in a PR, okay, that will automatically bump the NPM versions in the cloud, okay? So instead of you having to create now a new, so instead of actually so you're coding open source release automatically. So you're coding open source release automatically, updates rather than after. But again, it's for this. So let's say you're working let's say you're working on your SaaS, okay? Because this is something that is in demand. So one of the use case of your GitHub Actions, according to Steve Keeney, that he's working for Temporal, and it has this open source. So they have now the open source and the source code, or they have the open source in a public repo and the SaaS code on a private. So anytime they want to bump up the NPM version of the open source, okay, so when we bump up the NPM versions in a PR, it will automatically bump the NPM versions to the cloud. So instead of actually having to manually do this release, so for example, hey, I create now this change. Let's go to merge that to change, and then now to publish that. And then if you need to do another update, you're going to create a new open, or you're going to create is a new PR, merge to master, exactly. And this is if you want to, this is if you want to update dependency, for example. So instead of, oh crap, okay, so instead of you having to update dependencies manually, okay, by creating this individual PR of each one of them, which is something that you can do, okay, this say, hey, let's go to create now a script that when you detect a bump in when we bump up the NPM version in a PR, you automatically detect that and bump up and bump up the NPM version in the cloud. Okay. So this is also interesting because now they split, so they have now the fronting and the backing code in the same repo. Okay, that's interesting. So they have this monolithic. They realize like no, this is causing a lot of trouble. That kind of thing. No, they put the fronting and the backing in the same repo. So yeah, so you get the idea. Workflows can signal other workflows. And the other is a label fronting and backend code on pairs.
We're going to build it. We're going to like create a workflow, right? 5 minutes off of it every month. That kind of crazy stuff.
Wait, what? So, alright. Wait, what preview? No. What are you doing? Oh. Oh my god. Oh my god, what the hell is it? Spend 2 full days building real world application using React Native. Oh my god, this will never end. This will never end, bro. This will never end.
All right, so just for fun, this is an example of a dribble animation that we would take a look at and try to read this animation using, well, in this case, just CSS. Showing both our animations, just barely, and examples dribble. Okay, good enough, good start. We're showing the first one, and then we're both zooming out and showing the second one. So let me just grab the color of this second one real quick. Just want to think in like series of steps. So the first step, we'll just do the headings to do that. Translate Y, let's bar or swipe, and have from to come back in like that. So there we go. Okay. Oh, come on. I forgot there is no second child. There's nth child too. Okay. Here we go. So this does that. And then there we go. So the last part of this is, we want to on. And so this, here, let me just show you this because it's really, really useful. There is a clip path maker over here. And so basically for clip path data, I'm going to do this clip. Fourth one is at 0%, 100%. And the last thing I want to do is I want to just change how this, this headings thing is just because it's moving a little bit too far. So there we go. Yeah.
Clip path, that's pretty sweet. I've seen a lot of like kind of like a background color full div that kind of just moves out and like does a reveal as well for that effect. But I think that was pretty sharp.
Yeah. So
Anyway, that's not relevant.
all right. So
that's not
just
relevant.
for fun,
that's not
this is an
relevant.
example
that's
of a
not relevant.
dribble animation that.
Okay. Yeah, that's not relevant. That's not relevant. Not doing stuff is much faster than doing stuff. Okay. UI. Enterprise completely. That's right. Not doing stuff is way much faster than doing it. Okay. Okay.
And we're going to build it. We're going to like create a workflow that basically runs our test suite. Like I said, any repo that you have will work in this case. They begin to like publish your first workflow, and I'm gonna kind of just go into, if I go into the README, and we can kind of jump into one of the sections, getting started with GitHub Actions. Let's look at what a first workflow might look like. Okay. This is possibly, I'm not gonna say the simplest workflow, because I could have one just like echo something, and that would technically work. But this is like the smallest useful workflow that you might see. And so this would be in like .github directory in a workflows folder that we'll make in a second. Don't worry about that. Let's just kind of talk about the component pieces in here. And then this is possibly, I'm not gonna say the simplest workflow, because I could have one just like echo something, and that would technically work. But this is like the smallest useful workflow that you might see. And so this would be in like .github directory in a workflows folder that we'll make in a second. Don't worry about that. Let's just kind of talk about the component pieces in here, and then we will go ahead and we will put it in our repo and watch it do its thing. So the name, that's pretty straightforward. It's what name do you want to see? And so like I might even do like run unit tests or something like that. But anyway, the more important part that comes next is like, what triggers this workflow? Like I said before, you could do it on basically anything. Issue being created, a pull request open. There is a long list that I have linked to here as well. You actually are in the repo.
So what it's doing is now behind the scenes, their servers are creating a process.
We'll take a look at it in a second. There's a long list of things, and for those things, there are even like nuances to what you can only do when an issue is like closed, or you can only if the PR is a draft. There's all sorts of like little things you can do here.
So let's get into this. So we are in the content here. Oh, that's quite wild. That's quite wild. Filtering time, faking time. Good. Oh, yeah, interesting. Holy shit, bro. Holy S, bro. Wow, that's massive. That's massive. Deep. That's massive. Getting started with GitHub. Good content. Generating starting with GitHub. That's massive. Input obstacle. Interacting with DOM. Using testing library. Holy S. Oh my god. That's quite Ghibli no refs. Writing some simple playwright tests. Okay. But go to the file. Is getting started with GitHub Actions. Okay. The high level. GitHub Action is a system for running workflows on GitHub infrastructure. Do stuff when things happen. More specifically, your GitHub Actions workflow live in the .github/workflow directory in your repo. So GitHub Actions will trigger when an event happen and kick off, and they specify is all of this series of events. That's quite interesting. So most of the time you have this particular events that are triggering based on the branch. So you have branch protection rule, check run, deployment, fork, discussion, merge, project, pull request, all of this event that was defined by GitHub infrastructure that you can act upon and do something. Exactly. So to kick off a workflow that consists of one or more jobs. So first, a look at this. So we're gonna detect is on push and pull requests, and we're specifying is the particular detection. It's like, hey, the main, all right, makes sense. The other is the job that you're gonna do when this happens. When someone wants to push to a brand, or here, you want us to now provide the name here, the environment you're gonna run, or the OS, as well as a series of steps to do. Okay. Okay, so what's going on here? Name, simplify the name of the workflow, on what kind of event we're listening to. Exactly. Job is a list of jobs that will run in parallel. Interesting. Right now we have one, and it is called build and test. Step, each job has one or more step here. But this is a list of jobs that will run in parallel. In parallel, it was run in series. I think they will run in series. I think they will run in series. No, perplexity. Exactly. Time, bro, time. No. I want the answer quickly. Is job. Exactly. So is job in a GitHub YAML file workflow run jobs in parallel, okay, or in series? There you got it. GitHub Actions allow jobs within a workflow to run in parallel by default, which can significantly enhance the efficiency of continuous integration and deployment process. Okay. So you can define. Okay, it's interesting. You can define. Okay, control over execution. Concurrency management. GitHub Actions also provide options to manage concurrency through the concurrency keyword. This allows you to limit the number of concurring jobs or workflows can run simultaneously. Okay. Control of concurrency of workflows and jobs. Run a single job at a time. Okay, using concurrency to cancel any progress of the job. That's quite interesting. That's very interesting. Okay, so this is a list of jobs that run in parallel. Right now we only have one, and it is called build and test. So you can tell now to the GitHub servers that is going to run this workflow using a particular process, and then run these several tests, run these several jobs in parallel. That's quite interesting. Why this is the use case for this? I will argue that if you want to test, if you want to build and test in several OS.
But you know, for a very simple like first workflow, we've got on, which is like what event are we listening for, and we are going to listen to one of two different events: a push to a particular branch. You can guess which branch that is by squinting and looking at it, or a pull request targeting a particular branch. Right? You will notice that the branch in question here is main. Right? Is to say that like, hey, whenever someone pushes to main, right, which is usually if you've turned on any kind of branch protections, means that they've merged a PR into main. Let's run everything one more time. Run the test, why not? Also, whenever somebody opens a pull request against main, the nuance here is that event also triggers when they push to that pull request, right? So all PRs and any commits to those PRs, as well as pushes into main itself, will trigger this workflow. For tasting notes, you can do like pattern matching here. So it could be like, if you got a feature branch, right, which is feature dash, it could be anything to a feature branch. Right. In fact, like I say this particularly because I recently got bit by this one, which is in December we decided not to release anything because we didn't want to work for the second half of the month. So we made a feature. We made like a code freeze branch. I think I called it Long December after the Counting Crows song. I don't even like the Counting Crows. I don't know if that was I don't like the Counting Crows upset or like even a Counting Crows reference upset. I don't dislike them, I just don't like them. Like, it's the absence of a failure as a passing test, right?
It's the absence of failure is a passing test, right? If there is nothing in there, it's like, it's a passing test.
And so this was set to main, which meant that all of the PRs we opened against that code freeze branch didn't have our CI/CD process run against it. Right? Which was a lot of fun when it was time to then merge that branch into main, right? So you could theoretically comma separate. You could do pattern matching, which is like feature dash, like a wildcard. I say this because I didn't do that and I suffered the consequences, right? Like, I will leave it as an exercise to the viewer/reader how much of the content of this workshop is things that have bitten me in the last 18 months, right? And so here we got any of those against main, and then we have jobs.
That's interesting. So the branch allows you to put that in a okay. It's our immigration. Oh my god. Code space pull request gets CD GitHub Actions. Jesus. Writing workflows. Okay. About workflows. Triggering a workflow. Okay. Using trigger in GitHub Actions. Create a dependent job using a matrix. Exactly. And catching dependency using database and service container. Interesting. Using labels to route workflow and that kind of thing. So this is a particularly working in itself, bro. Using workflow templates. Okay. Quick start for repository, about branch, and about pull request. Create your first workflow. Perhaps the reference will help me here. You know. Yeah, the reference. Query reference. Okay. A GitHub Actions. GitHub Actions reference. Anyway, where can I find GitHub Actions reference page? This is for creating actions. Okay. Understanding GitHub. Write workflows. Workflow syntax. Exactly. Okay. Workflow syntax, bro. Perfect. And when you have jobs, a workflow run is made of one or more jobs here. So the question here is that you can run all of this. This is now the structure of this is the anatomy here. Hey, this you have a name, have permissions. Runs on it's not on jobs. I mean, it's on workflow, exactly. So it's on when you can now define pull request like this on push, on an event type. Okay, you can put a label to that. That's quite interesting. On push, on fork to define multiple events. What you want to do when that happens. Event that trigger workflows. Even here like this, using filters. That's quite interesting. Using activity type and filtering with multiple events. Okay. So any release, I want you to now run this job. So is there any release? I want to run this job. Okay. Okay. That's quite compelling. Yeah, that's quite compelling. That's quite compelling. Okay, cool.
Jobs are things, depending on how fast you would like things to be. You can run on just like, give me like an Ubuntu server you have laying around, I'll take it. However, let's say hypothetically we're building an Electron app, right? Well, you got to build an Electron app on whatever OS you want to run that Electron on. So like you can signify Mac OS, you can signify Windows. That said, like as most of you all know, Mac Minis are more expensive than like a Linux box, right? That translates down into like how many Linux, like generally speaking, choosing like Ubuntu is going to be like have the best network throughput. It's like what the internet is built on, right? You want to get fancy and like if you need to like compile some like Windows things, or you need to use Xcode, then you got to use that OS, right? But if you don't really care, if you're just trying to take some text JavaScript and make it some smaller text JavaScript, anything will work, so we'll use Ubuntu latest. There are some other options here. You can have like jobs that rely on the completion of another job. We'll get to that later. Then the most important part are these steps. And really, this actually really well suits like all the basic things you can do, which is you can either run what we'll call an action. You can, let's say, use an action because like words mean things. You can use an action, which is basically just a different YAML file with different commands in it. Or you can run a command. The one nuance here is that you look like these look like bash commands. Fun fact, they are. The one nice part is your workflow actions are either YAML like this, so like even when we break stuff out into its own action later on this course, we're going to do it in YAML. The nice part is the other way that you can write an action other than just shell scripts and run is JavaScript. So the nice part about being a JavaScript engineer in 2020, whatever year it is.
Can use wildcard.
And so those are kind of the pieces. So like we step through the steps and we can kind of see each piece. So this is a pre-built action that we say uses, right? And so this is already built and we're just kind of referencing it. Which is anything with action slash is usually...
Exactly. So jobs are running... So jobs are running in parallel. So running in parallel. Parallel.
Built by GitHub, right? Because it's just that is org/repo is really what that is. The same way like you might have GitHub org or your username / your repo name. Org/repo, they own actions. Checkout. Would anyone like to venture a wild guess what action / checkout does? Add more detail or something like that at the same time. And you could shell scripts or yeah. So read my notes back to me.
it's a variation on npm install with a few different caveats.
Oh, yeah?
It insists on having a package lock JSON.
Yeah.
It'll error out instead of updating package lock JSON. If something doesn't match, that seems incredibly useful.
Yeah.
It deletes node modules at present. It doesn't write to package JSON. It'll install all dependencies.
Yep. So it'll basically do that thing where we all do, even if it doesn't work, but like assign that just name something.yaml with this code in it, and you now have your unit test running on every PR to main. Let's do it.
Mm-hmm.
Like I said, you can grab any repo you have. You can use this one. Tomorrow we'll have another repo that we'll use and stuff like that. But you just don't have push access to my repo, so you would have to fully fork it and not just clone it at that point. But I'm going to just make a new branch. Cool. And we can go in here and we'll make a new folder. And I hate how VS Code really doesn't ever want me to put anything on the top level. Let's go down here and do it.
So, so that'll be all for this video. Take care. Bye-bye.